Welcome to Module 2, Part B. This module is part of the screening dimension of the 4S model, which helps us to answer the question, what type of project is our project and what type of complexity is associated to our project. So when we are analyzing a project, the first thing that we need to do is to use the screening dimension of the 4S model. Within the screening dimension, next, we can use either the 8-feature model or the Kinetic model in order to know what type of project is our project. And in Module 3, we will see the diamond model, which help us to know how complex is our project. In this unit, we focus on the Kinetic model. The Kinetic framework connects the project with the nature of its context. Kinetic model help us to recognize different types of complexity associated to projects by considering the context in which projects unfold. Before explaining the Kinetic framework, we need to provide some information regarding complexity, since the Kinetic framework is based on complexity theory. Complexity in management is related to perception and ambiguity. Most of us see a situation as complex when there is information or events that do not make sense. One of the reasons is that we don't know what to do. Then, when we are facing multiple conflicting demands, we usually use conventional management thinking to solve problems. That is, consciously or unconsciously, we assume that the world is predictable and orderly. Based on that assumption, we simplify the problem. This strategy works only in ordered, predictable contexts. In the case of complex environments, we are using the wrong frames or lenses if we use that strategy of simplification to interpret the world. The Kinetic model helps us to interpret the world in different ways. We need to remember that there is no universal model to manage complexity, since there are different types of complexity and different levels of complexity. In other words, no framework will account for all situations. Then, a key management skill is to deliberately change the level of analysis or the angle of analysis when we are looking at a particular specific issue. It is necessary to recognize that any system can be viewed from multiple perspectives. In this figure, you can see the arrow, the red arrow and the green arrow will see different things from the same phenomenon. All perspectives highlight some aspects of a situation and blind you from other aspects of the situation. A very good example that summarizes these ideas of different angles of analysis and predictable and unpredictable context is the following examples. An experienced chef, for example, will be able to prepare a nice food with any raw material that you present to him or her. However, a recipe book cooker will do a nice dish only if he or she have all the instructions step by step, and it will succeed as long as the raw materials are the same as the recipe and that he or she do have the adequate cooking hardware. That is, a recipe book, Cooker, works in the world of predictability, and it will be successful as long as he or she have all the raw materials and the environment is stable. However, an experienced chef will do any nice food with whatever raw material. He will be able to what we call improvise maybe, but he is acting in the world of unpredictability, and that is the reason why he is successful. He knows how to deal with unpredictable environments. So, what is complexity? Complexity is a way of thinking about the world. Complexity is a perspective. Complexity is not a mathematical model. A complex system is an open system, and a system is a network composed of interrelated parts. The system may or may not have a purpose. And open systems are systems that interact with other systems. That means it can affect other systems and it can be affected by other systems. Components of a system are agents. Agents can be humans or can be non humans, such as materials, computers, animals, and objects, software, hardware. So humans, however, are different than non-humans, obviously. Humans may have multiple identities, multiple hats, multiple roles, and they can switch those roles at any moment. Humans make decisions based on past patterns of success or failure rather than logic. So complexity is related not only to open systems, but it is related to interactions between elements of the systems that are nonlinear. This means that minor changes in a system may produce major consequences. Systems are also dynamic because the outcomes may emerge from interactions between different elements. And later we will talk about emergence. As external conditions of the system continuously change, the system needs to be adapted to these new external conditions. And finally, we know that agents and systems constrain one to another in complex projects. And this explains why it is not possible to make predictions about human behavior. So, how do we recognize a complex project? Here we have a sort of summary of the key features of complex projects. Projects are complex when there are a large number of variables and interfaces between their elements, when there is ambiguity regarding events and causality of events, when there is uncertainty and unpredictability regarding what will happen and how it will happen. Also, when there is a rapid rate of changes, either in the project or in the context, that is, there is dynamics. And finally, we need to look at the number of human relationships or human interactions in the project. The higher the number of human interactions needed in order to develop the project, the more complex. Another way to think about complexity is about by relating quantity of elements of a system, ambiguity of its elements, and their interconnections. Complexity, we know that is the result of interrelationships between components. However, the outcomes of those interrelations may have a higher or lower degree of uncertainty. In situations where components produce a high level of uncertainty regarding its outcomes and or behavior, the level of complexity increases. It is the ambiguity created between different interconnected parts of the system that creates this perception of complexity. The number of interconnected elements or components of the system is an important indicator of complexity. In this example, for example, we can see, imagine that this is a system that can be a project, and in this project, the blue circles represent well-defined components of the project. That is, they are stable, they have clear goals and clear procedures and clear outcomes. The white circle represents a part of the system that is ambiguous. Ambiguous can be related to the completion time of a task, or when will start this task, or how the unit will do this task, or what exactly they will do it. The point is that there is complexity. So as you can see here in this system, there are 6 components. And the blue circles are components that are stable. They have one input, one clear process, and one clear output. There's no mistake. They're stable parts. However, the white circle let's imagine that they are 4 possibilities or 4 possible configurations or 4 possible actions that the white unit or white element can develop. Then this means that the whole system or the whole project, there are likely to be 4 possible outcomes at the end of the project, because there are 4 different configurations that the whole system can take, and this depends on the 4 alternative configurations of the white circle. In this case, we have the same structure with 6 components. However, 3 of these components are ambiguous. Each component has 4 possible ways of acting, or 4 possible different outcomes, possible outcomes. The solution in this system, or the number of possible solutions in this system, are 64. And this means that this system is much more complex than the previous one, despite having the same number of elements, 6 elements. In this example, we show a larger project. We have 15 different elements, and from those 15 different elements, 8 elements are ambiguous. That is, each of those 8 elements may have different outcomes. And in this case, we are assuming again that each of those ambiguous elements may have only 4 different outcomes. All this means that the final solution or the final result of this system is more than 65,000 possibilities of different outcomes. And this means that the project is very complex because there are too many possible outcomes. And this example is a very clear example of how the quantity of elements of a system and the number of ambiguous elements of that system exponentially increases the complexity of a system. In summary, a complex system is an open system in which some of its elements have ambiguity and uncertainty regarding what will happen and how it will happen and what are the outcomes. Next, the whole system is in constant adaptation relating to its context. Also, during the system, there is emergence and self-organization. In the following slides, we will talk a bit about self-organization. Please watch this video, What is a Complex System? And think about those discussion questions so we can talk about them during our workshops and collaborate sessions. We will develop this activity during our workshops and collaborate sessions. In order to clarify the concept of emergence, please watch this video and attempt to answer these two questions. We will discuss them during the workshops and collaborate sessions. After explaining the concept of complexity, now we turn our attention to the actual kinetic model. Kinefin is Welsh that means the multiple factors in an environment that affect us and we cannot understand. The Kinefin framework allows people to see problems from different perspectives. Kinefin helps us to sort out prevailing contextual situations so we can make appropriate choices. Kinefin is a tool for exploration of possibilities and generation of new ideas. It will not recommend us a specific course of actions. So, the Kinefin framework helps us to make sense different forms of complexity associated with dynamic and uncertain situations. It helps us to think about the nature, the character of our project. Before detailing the actual kinefin, it is necessary to understand the relationship between different worlds that exist, different domains, let's say. In the first domain is the ordered domain. In this domain is when there is rationality. There are clear interrelationships between the elements, and we know very well the cause and effect relationships between those elements. So, it is possible to develop general rules in order to work in the domain of order. On the left-hand side of the slide, we can see the domain of an order or emergent order. In this domain, the interrelationships between agents or elements of the system are unclear. The prevailing cause and effect relations are unknown. So, it is not possible to develop general rules in order to know how do we act in this domain. Depending on the project, depending if your project is either in the order domain or in the unordered domain, you will need to use different tools and different methodologies in order to account for the level of complexity that is associated to each domain. One way to further explain the order and the unordered domain and to see how the use of specific project management models fit or do not fit in those different domains is the case of the birthday party case. Let's pretend that we need to organize, and this is our project, a birthday party for a 10-year-old child. Now let's pretend that I am organizing, so I assume that this is an ordered system. So I set clear learning objectives for the party and I develop a plan. The plan will have milestones so I can measure progress. And I start the party with a motivational video and use PowerPoint in order to motivate children and tell them what they will do. And I use pocket money as a way to incentivize children to achieve the goals. So the plan is that after the PowerPoint, children will do painting. After that is chocolate cake. After that is reading a story. And next is ice cream. The result of this party is usually a disaster. Why? Because children do not listen. They are not interested in money. They fight one to each other. And they want to swim in the swimming pool, but they are not allowed. And even if they are not allowed, they swim there anyway, and they get wet, and parents are annoyed, children get dirty, children get crying, and that party, of course, becomes a disaster. One explanation is because the main assumptions of this order system is that we can control the agents or the elements of the party, that is, we can control the children. That is wrong. Second is that we can control the interactions among the elements of the party. We can, that means we can control the interactions between different children. Wrong. We cannot control that too. Third, that we know the cause and effect relationships. We do not know what are the outcomes of those interactions between different children. And finally, we assume that because the system is stable, we can apply standard operating procedures. That is, if we offer money to children, they will be happy. If we offer ice cream, they will be happy. If we tell them to paint, they will do it. That doesn't work. And this is an assumption, again, of an ordered system. Now, if we organize the same party thinking that we are in an order system, we need to assume, one, from the beginning, in an order environments that are suitable for complex projects, we need to assume that it is not possible to control all key agents. That is, it's not possible to control all children. The cause and effect relationships are only known in retrospective. Beforehand, we cannot know how one children will relate with another children. So in this case, we can just manage patterns. We cannot manage agents. So how do we organize a project in this unordered situation? In this case, we draw a line. That is, we tell children and parents, these are things that are allowed to do, and these are things that are not allowed to do. In the case of the swimming pool, if we don't want anybody go to the swimming pool, we will not only shut down, but also try to put some fabric to hide the swimming pool, so children will be unable to see the swimming pool and they will not want to go to the swimming pool. And also we need to be flexible. We can, for example, offer different alternatives at the same time to children, such as football, computer games, dancing, ice cream, painting, and we will just observe how these different stations or items or events go, and whatever things go wrong, we will stop, and whatever things go right, we will continue using. So in this way, we cannot plan in advance everything, but we can have a more or less outcome that is similar to the outcomes that we want to achieve. In the video Birthday Party Allegory, you can have more detailed explanations about this example. But the key point here is to recognize that there are different domains, and different domains need different ways of managing projects. The kinetic model is a sense-making model. That is, it helps to sense-make specific situations. It looks at the relationships between different components of a system. It is a framework that helps to recognize the causal nature of different systems. As you can see here in the screen, it has four different contexts. The first one is the simple context. Here, there are linear cause and effect relationships. Events repeat themselves, so it is possible to construct predictive models such as standard operating procedures. The focus in this type of context is on efficiency, manuals, and operating procedures. This is the world of the known knowns. The decision-making model in this context is sense incoming data, categorize that data, and finally respond using predetermined practice such as standard operating procedures. For example, if our project is a simple project of going from Gold Coast to Brisbane by train, first we need to get data. That is, I go to the website and see the timetable. Second, I categorize that data. That is, by looking at the data, I will see what is the most convenient time for me to go to the train station to get a specific train. And finally, I applied a standard operating procedure. That is, if there is a departing time, I will know what time I need to leave my home to have time to drive and to park and to buy a ticket on the train station. That is a standard operating procedure, and this is the simple context in which things repeat itself, and because of that it is possible to have standard operating procedures. Remember, elements in these systems are stable. They do not change, or they change very little. The next type of project, or the next context in which projects unfold, are what we call complicated projects or situations. Here, there are stable cause and effect relations, but they are difficult to know. Probably because there are too many elements and too many cause and effect relations, so it is not easy to know them. So there's the need of extensive analysis to uncover those relationships. The elements of the system, they have relationships, but those relationships are separated in time and space. This means that some elements in the systems, for example, can make some decisions today, and other elements in the systems can make other decisions in a month's time. At some point in the future, these two decisions will interact and will create a specific output. That is why it is very difficult to predict the output of this relationship between these two agents or elements that are separated in time and space. So what do we do in these cases? We use experimentation, we use expert opinion, and we use scenario planning as an appropriate tools in order to deal with complicated situations. In complicated situations, there are multiple right answers, there are multiple solutions. This is the world of the known unknowns. The difficulty is to know how do we choose what is the best or the more feasible or the appropriate solution, because there are too many different solutions. The decision-making model in the complicated project is first sensing incoming data, second and most importantly analyze this data, and third response. And I will give you a very simple example of developing your assignment number 1 in this course. First, you need to get the data, sense incoming data. So how do you get that data? You will read the case studies or use your own experience, and you will read the theory, watch the videos. So you get the data. Stage number 2, you need to analyze the situation. That is, you need to analyze because the relationships between the theory and the specific cases are separated in time and space. And you need to find the connections between those relations, that is, between the connections between the concepts and the data. And that will be your analysis. And the final stage will be response. That is, you need to develop your arguments to achieve your goals. And that is the complicated situation, context situation. The next is the complex context situation. In this scenario, cause and effect relationships are coherent only in retrospect. It is not possible to know in advance those cause and effect relationships. There is significant unpredictability, and we can only observe patterns. So what we can do in this situation is to prove, to experience, to do experiments that are safe to fail in order to observe emerging patterns. When we find emerging patterns, we will be able to think in particular or more specific solutions. And the only way to observe emerging patterns is by doing experiences in which it is safe to fail. The decision-making model, therefore, in the complex situation is first proof, that is to try, and that is the most important one, that is to do trial and errors, really experimentations, in order to see what patterns emerge. Next, we can sense incoming data and respond. A very good example of the complex situation is the case of the Deepwater Horizon before the explosion. The causes of the explosion in this case were the results of many decisions and actions made by many different people at different stages, well before the actual explosion. There were administrative, there were technological, and there were economic reasons or type of decisions that were made, and all those decisions combined in such a way that caused the explosion. There was also unpredictability regarding technology. Will the technology that we have will work? It was unpredictable. There was also unpredictability regarding the context, and in this case, I'm talking about the physical context under the seabed. It was the first time that anybody was drilling oil at such a depth. And so, will the context will change? Will the pressure that exists under the seabed, it is something that we know how to cope with that? They assumed that yes, but they were wrong, of course. The idea is that they had to do many different experiences before doing that, before the actual drilling, in order to observe patterns, in order to form some guiding principles. They didn't. In the case of the Deepwater Horizon, what's happening is that they were in a complex situation, but they act as if they were in a complicated project. So they try to use their standard operation procedures to analyze and to solve problems. Didn't work because they were in a complex situation, but they act as if they were in a complicated project. So the complex situation is the situation of the unknown unknowns. And the final type of project or context is chaos. In the chaos situation, searching for right answers is pointless. It is impossible to determine cause and effect relationships. This is because relationships shift continuously and there's no pattern. There's only turbulence. So it is not possible to analyze, it is not possible to wait for patterns to emerge because there are no patterns that will emerge, and you will just waste your time if you are trying to analyze or waiting for patterns to emerge. So in these cases, the focus is to move to a state of stability. And the decision-making model, as you can see, is first act quickly in order to reduce that turbulence. Second, you need to sense the reactions in order to respond. And third, you need to focus on multiple small interventions in order to restore stability. The key point here is to get out of that chaos situation as soon as possible, because chaos situation is destruction, really. After that, you will think on why and how, but the first point is to get out of that chaos situation. And of course, you can do this by, as I already mentioned, by doing multiple small interventions in order to restore this stability. Some will work and some will not work. You will go with what works, of course. And the cow situation, there are many examples, unfortunately. A, a very clear example is the COVID situation in early 2020s. In all countries, this was a cow situation. Governments and people did not know what was happening, what was going on, did not know, of course, how to respond, did not know the extent of the infections of this COVID situation. Another example of cow situation is the 9/11 event. So in these two examples, you can see that looking for right answer was pointless, right? It was impossible in early 2020 to determine the cause and the effects of the COVID-19 pandemic. And actually, it was useless. The key point is to try to get away from the pandemic situation. And over time, of course, some countries were able to find patterns because they saw patterns to emerge. And the first thing that some countries that did, such as New Zealand, was the first one of the first one, was to stop incoming flying from overseas because, of course, people who came from other countries were carrying that virus. And, and after that, they implemented again other different measures in order to try to see what works and what does not work. Uh, so, in simple terms, this is the idea of the kinetic model. Remember, there are four different situations, right? The, the simple and the complicated situations or projects play or unfold under an ordered domain. And the complex and the chaos situations unfold under the unordered domain. So we need to, they are different. The response on what do we do in each case need to be different because they are different systems. Different types of complexity are associated to each of one of these four types. Before we go to the next slide, I just want to recommend to you strongly to read the Snowden and Bone Harvard Business Review paper, that is one of the prescribed readings, because David Snowden, that is the father of the kinetic model, explains very clearly the concept of the kinetic model and the complexity concepts that are associated to this model. Because the kinetic model is a very powerful model, but it's not difficult, but it's tricky to really to understand because it's a different model. I have put here two videos for you to watch on your own time. This video is a simple explanation of three types of context in the kinetic model. Please watch it on your own time. Here you can find additional details about the simple context. Please read it on your own time. Here you can see additional details of the complicated context. In this slide, you can see details of the complex context idea. Finally, here you will find additional information regarding the chaos context. At this point, everybody must attempt to apply the kinetic model to their bridge building case. We will discuss this case in the face-to-face workshops and in the online sessions. Please Apply the Kinetic Model also to the digital equipment case. We will discuss this case in the workshop and in the online collaboration sessions.